Good afternoon, everybody. Myself, Acharya Vishvendra, and today I'm going to discuss a worksheet on a refraction at a spherical surface. So let's discuss the worksheet. So here is the worksheet on refraction by spherical surface. So we are being given a spherical surface. For this side, mu is equals to 2. For this side, mu is 3. An object AB having height of 4 mm is placed over here. Radius is 10 centimeter and the distance of this from the pole is 20 centimeter. So the first question is x coordinate of image. So using the equation mu2 by v minus mu1 by u is mu2 minus mu1 by r, and after solutions we have v is equals to minus 15 centimeter. So x coordinate of the image is minus 15. Next is y coordinate of the image. So using this equation, suppose angle of incidence is theta and angle of refraction is alpha. So mu into theta is small, so we can take that as theta, and 3 into alpha, and it is equal to after calculations we have height as 2 mm. Next is y coordinate of image. So magnification is hi by ho, which is v by u into mu1 by v2. So after solving we get magnification as 1 by 2 and height as 2 mm. So we can also calculate using this. So in this way we can calculate height. Next is height of images, as calculated it is 2 mm. Next is there are two surfaces having radii 10 centimeter and 20 centimeter respectively, and we need to find location of first image. So for this interface we can use mu2 by v minus mu1 by v. U is mu2 minus mu1 by r, taking u as minus infinity, so v comes out to be 15 centimeter. So first image is located at 15 centimeter. Next is second image. So this image will act as object for this lens, so this distance will be 5. Again, using the equation we need to find v2, and v2 here is minus 80 by 13. So that is location of second image. In the next question we are being given light is incident at an angle 60 degree. It gets refracted at I, and here angle is I dash and this angle is R. So first is we need to find I. So applying Snell's law at this interface, we have 1 into sine 60 is root 3 by 2 into sine I, and after calculations we have I is 45 degree. Now inside the sphere, as radius is same, so in this triangle both angles will be same. So from there I dash is also equal to 45. Next is angle R is. So using the equation of Snell's law at this interface we have R as 60 degree. Next is deviation is. So deviation is the difference of these angles. As you can see from here that this angle is I plus I dash, and the light ray makes an angle R with this. So this angle here is 60. So take this as the reference line. So this angle is I plus I dash. So here this reference line, this angle is I plus I dash, which is equal to 90 degree. Now this light ray makes an angle of R with this line. So this angle here it represents the refracted line, and this angle is R or 60 degree. So if we draw line parallel to x-axis, so this light ray makes an angle of I plus I dash minus 60, which will be ultimately 30 degree for R. And if we see the initial incident ray, that will make angle of 60 degree. From here it is 60, so this angle is also equal to 60 degree. So if we draw both the lines, then I makes an angle of 60 degree with x-axis and R makes an angle of 30 degree. So this deviation is 30 degree over here. So from here we can calculate the deviations. Next is we are being given a question based on refraction by spherical surface. There are two objects, O1 and O2. Mu is 2 over here, mu is 3 over here. Then first is location of first image of O1 is. So using the equation mu2 by v minus mu1 by u is mu2 minus mu1 by r. We have v1 as minus 180 centimeter. Then is location of image of O2. So using the same equation, we have V2 tends to infinity. Next is difference between image of O1 and O2, so that is obviously infinity. Next is we have another spherical surface and a plane mirror, and light is incident parallel to the interface as shown in the figure. We need to find location of first image. So using equation of refraction at a spherical interface, we have V is equals to 20 centimeter. Then this distance is 30. So from this interface, image is the first image will be like here I1, and this distance is 20. So this distance is going to be 10 centimeter. So I1 is at a distance of 10 centimeter from plane mirror. So mirror will form image at I2, which is at a distance of 10 centimeter. So the location of second image is at a distance of 10 centimeter inside the mirror, and it will act as a object for this. So for this interface, the distance of I2 from here will be 40 centimeter, and using the refraction law at a spherical interface, we have V is equals to minus 20. So finally I3 will be at a distance of 20 centimeter from this curved surface, or let us say this point is O. So from O. So location of final image will be 20 centimeter from here.